Hello everybody and welcome to this next video. We're going to do a walkthrough of a paper 2 for the syllabus 9618, which was May-June 2023. I had a quick look at the mark scheme and I saw some of the questions, but I haven't really worked it out yet, and it's been a long time since I've done pseudocode, so let's hope I don't make too many mistakes. If I do make a mistake, please let me know in the comments. Also, one reason why I didn't want to work it out in advance before recording the video is because in real life, solving these papers involves a lot of head scratching and a lot of messing about. So I didn't want to give you the false impression that you need to do everything right the first time. Realistically, on the paper you expect you might create a bit of a mess. That illustrates the point of why it's so important to get practice in advance. Because the more practice you get, the less mess you will make. So it's been a while since I've done Pseudocode, so I actually forgot quite a lot of stuff. So sometimes it might happen that I'm going to look up some syntax, which I can do because I'm not taking the exam. But you, on the other hand, are taking the exam, so you're going to need to memorize as much as possible. Hopefully you'll memorize 100% of the syntax. And if you need help memorizing, have a look at this video, which goes over all the syntax using simple exercises. So let's have a look. I have my paper open and I also have the inset open over here. The inset is basically doesn't change much year on year. I haven't really noticed any changes. So it's a good idea to be very familiar with this inset. Let's get started. The first question is actually already quite confusing in my opinion. So I can imagine that if you start and you're already completely confused in the very first question, it's a bit upsetting and it's a bit stressful. But if that happens to you in the exam, please don't panic, just keep calm, move on to the next question and try to do that one, and just keep working, and once you've done the paper, come back to this question. So what I find confusing about this question, let's read the question first. A program calculates a postal code based on the weight of the item and its destination. Calculations occur at various points in the program, and these results in the choice of several possible postal codes. The programmer has built these postal codes into the program. For example, the postal cost is $3.75 is used in the following lines of pseudocode. Question A1, identify a more appropriate way of representing the postal codes. So this actually, when I read this, I actually got quite confused and I had to go back and I had to reread the question. And when I reread the question, I saw a very important keyword, which is several. And from this, I know if you're not a native English speaker, it kind of gives you a disadvantage. But several means one or two or three or more, right? So it's basically, we only have a finite list of options in the postal codes, with postal costs, excuse me. We don't have a continuum of possible postal costs. There's only a finite number, like for example 4 or 5 possible values that the item postal cost can have. And from that I was like, okay, we have to use enum. But then I remember that we don't even learn enum for paper 2. We need to learn about enum for paper 3. So that got me really confused. And I went to the mark scheme and I found out that actually, yes, I was right. But instead of writing enum, if you don't know what enum is, don't worry about it. You're going to learn about it later. Anyway, we don't need to use enum. In this case, we need to use constants. So yes, I cheated a bit and I looked at the mark scheme to answer this question. Which just goes to show, don't feel bad if you don't know. Don't feel bad if you already got the very first question wrong. don't panic. It's probably just it's probably just exceptional question that's a bit confusing. The rest of the questions will probably be easy. Okay, the other way we could figure out that we need to use constants is that we have a condition here. If the weight is less than 250 and the address is valid, in that case, this is the postal cost. So when you're saying use constants, I believe they mean we will have a constant for item postal cost low equals and then a constant value like 1.2 or whatever. Item postal cost medium, a constant value for that. Item postal cost high, a constant value for that. And then which cost you use depends on a combination of circumstances like the weight and whether the valid address is true. There might be other circumstances like whether it's intercontinental or whether it's intercountry or interstate. All these combinations will result in a fixed postal cost, right? So it says use constants. If you were not able to answer this, you also won't be able to answer this one. So together it's 4 points. So you would already lose 4 points. I think it's a bit mean. But anyway, who am I to question the examination, the Cambridge? Who am I to question Cambridge? Okay, so what are the advantages? Now that we know we're using constants, what are the advantages? We can list some advantages. For example, the values cannot change after being defined first time, making the chance of bugs less. That's 1 point, I guess. Another advantage of using constants is if you need to change the constants, for example, if the postal service comes with new rules and regulations, you don't need to search for everywhere where the variable is assigned. You just need to change it once, probably at the top of the code. So if values change, then you only need to change it in code once. And what's a third one? Because we got 3 points here, so we ideally want to put 3 points. For example, I don't know. I'm just gonna put something nonsense. Hopefully I get the point, because I don't want to spend too much time on this question. So maybe I will write that it makes this code easier to read. Hopefully, I'll just hope for a point there, because it's a bit vague if I'm being honest. But I might get lucky. So why does it make the code easier to read? I think it's implied that because you cannot change the values, I don't know. I'll leave it like this. Maybe I'll come back later and fix it if I have time at the end of the when I finish the paper. If I have time, I might come back and think of rephrasing that question, or rephrasing that answer. Okay, the lines of pseudocode contain features that make them easier to understand. State 3 of these features. So first of all, we have comments. That's an easy one. It just says state, right? So we don't need to explain why comments are helpful. We just have to state that comments are helpful. Comments. code uses comments. Another thing is that the code uses indentation, so there's some space here, and it's very clear at a glance where the if starts and where the if ends. If we didn't use indentation, it wouldn't be that easy to see at a glance. Indentation. And the third example is that it uses variables which have common sense identifiers. Variable identifiers are descriptive, right? So it says here weight. We could also use a variable like W for weight, but then if we read this back later, we see W. W, what does W mean again? Then you're like thinking about it. Oh yeah, that's weight. But to be absolutely clear, we just write weight full out. We also write valid address full out. In fact, you might even write here is valid address, just to clarify that it's a Boolean. Let's see. Identifiers, a variable, identifiers are descriptive. We also have camel caps. I think camel caps is like, if I remember correctly, every identifier starts with a capital and each word in the identifier has a capital. But I think I've got 3 already and I'm confident about them, so I'll leave it like this. Okay, valid address is obviously a Boolean because it can only have a true or false value. Its value can only be true or false, and we can definitely see that it's being compared to a Boolean here, so it must be a Boolean. Item postal cost must be real. And item status must be string. This is a string. Okay, moving on. A program stores a user's date of birth using a variable myDob of type date. Write a pseudocode statement using the function from the insert to assign the value corresponding to 17/11/2007. I'm also somebody who is born in 2007. Far too young. Anyway, I'm just joking. So we got this variable myDob, my date of birth, and we want to assign it a value. So we use this arrow to assign it a value. And we're going to need the inset to look up how this function is used. Let's go over here. We've got string and character functions. And then we've got numeric functions and date functions, so it will be here. And we need this one. Set date. 3 parameters, day, month, year, which are supposed to be integers. And it returns date. Okay, what was it? Set date. Easy one, right? Set date. 17/11/2007. Great. 3 point. myDob has been assigned a valid value representing the user's date of birth. Write a pseudocode statement to calculate the number of months from the months of the user's birth until the end of the year and to assign this to the variable number months. For example, blah, 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 blah. So until the end of the year, 7 plus 5 equals 12, right? So we must do it in reverse. Num months gets the value, is assigned the value 12, the 12 months, minus the month of my job. So in this case it's going to be 11, right? And we want to extract the month from this job. So we're going to need the inset again. Month. It has a date as an input and it returns an integer, the month, right? Easy. Month of my dog. So excuse me. I'm not gonna use the eraser because that's cheating. I could actually use this eraser here, but I'm not gonna. I'm gonna simulate a real exam. It's gonna be just like, I'm gonna try to be as realistic as possible. Of course, I'm not writing this under exam conditions. But if I make a mistake, I'm gonna try to be honest and not edit the video. I'm gonna cross out and make corrections on the paper, just to try to give you a realistic idea of what the exam is really like. Okay, let's continue. The program will output the day of the week corresponding to my job. For example, the program will output Thursday. Great. An algorithm is required, or an array will be used to store the names of the days of the week. Define the array and describe the algorithm in 4 steps. Do not use pseudocode statements in your answer. Okay, we need an array. What kind of an array do we need? How long should the array be? So the array is going to store the days of the week. Yeah? So how many days are there in the week? It's obvious, 7 days. And what type of data do we need? Do we need to store an integer? No, we need to store the names. And how do we store names? String, obviously. So we gotta mention an array 7 long, and we gotta mention of type string. And declare an array of length 7 of type, sorry for my bad handwriting, string. Length 7. Good. Step 1. So what we're going to do in brief is we're going to get the day. So we're going to get, I think there's an inset function for that. We're going to get, we have my job, and we're going to get the number of the day of the week. Let's have a look at the inset. The number of the day index. Yeah? We put in a date, we get an integer, and it returns the day index, where Sunday is 1, Monday is 2, etc. So let's see. The day index is going to be, so we're gonna declare an integer that stores, declare an integer, named index, and assign the value and assign a value corresponding and assign, okay, I'm gonna cross it out, and assign the return value. and assign the return value. You see, I'm making a mess. That's okay. And assign the return value of the get index. What was it? The get the day index. Excuse me, the day. I have to be much more careful. The day index, because I'm going to make a mess. And the poor examiner is going to have a really hard time grading my paper. Declare an integer named index and assign the return value of the day index function. And I forgot that the day index function should take mydub as a parameter. Let's write it here. Which takes mydub as an argument. Okay. So we've got an integer in the index, and we're gonna use the index from step 1. Oh, you know what I forgot? Oh my goodness, I forgot to initialize the array. Okay. How am I gonna fix this? Okay, let's see. I'm gonna okay, let's cross this out. I hope this is gonna be accepted by the examiner. And then in step 2, I'm gonna say use the index. Oops. What happened? Use the index from step 2. In theory, it should be okay. In theory, anything that's written on the paper should be taken into account, even if you don't write on these dotted lines. Use the index from step 2 to access. Use the index from step 2 to access the appropriate string value. I knew I was forgetting something. In the array, and then output the value accessed in step 3. And now I'm going to go here and write step 1, and I'm going to write an arrow up here. Sorry. Oops, I made a mess. Output the value accessed in step 3. Step 1, initialize. Initialize with S, because British English. Initialize the array by giving the first by giving it values Sunday, Monday, etc. Remember, we need to start with Sunday, because Sunday is going to correspond to the first index in the correct order, starting on Sunday. I'm being very concise. starting with Sunday at index value 1. I want to clarify that I'm starting at index value 1 because sometimes arrays start at index value 0. I only declare the length 7, but let's just assume that it starts at index value 1 and it goes up to index value 7. Okay, this should be fine. Let me just save this before I lose my data. Okay, let's move on to the next question. A program stores the data in a text file. When the data is read from the file, it is placed in a queue. Okay, queue is easy, right? The diagram below is an ADT of the queue. Each data is stored in a separate location on the data structure. During the initial design, the queue is limited to holding a maximum of 10 items. The operation of this queue may be summarized as follows. The front queue pointer points to the next data item to be removed. The end queue pointer points to the last data item. So they're being pretty nice at telling us a lot about queues in case we forgot. But I think actually, in my opinion, queues are pretty easy to understand, except the last one might be just a little tricky. The queue is circular so that locations can be reused. So in case you forgot, what is a queue is just like a queue at the supermarket or at the post office. You just have to wait in line. So let's say you arrive to the post office and there's a queue of 5 people. You just have to join the back of the queue, of course. You don't join the front of the queue. And you just have to wait until the front of the queue gets processed. And when the front of the queue gets processed, you shift up 1 in the queue. So when you join the queue, the length of the queue increases by 1. And when the person in front of the queue is done, they leave, and the length of the queue decreases by 1. And the only difference with real life example is that the front of the queue keeps moving depending on where there is free space. But we're going to have a look at it. Describe how the data items orange and yellow are added to the queue, shown in the diagram. So first of all, let's say yellow is just arriving and sees 4 people in the queue already, 4 colors in the queue already. So yellow is going to find the end of the queue, and the end of the queue pointer points to the end of the queue. So yellow needs to stand behind that. So orange increases the queue pointer. So first thing we're going to do, first thing we really have to do is, it's fine. End of the queue pointer. Yellow looks at this specific situation and sees the queue is not full and says, let's increase the end of the queue pointer. So the end of queue pointer is increased. End of queue pointer is increased by 1. And then, i.e., okay, to 9, 1 to get the value of 9, to get the value of 9. This is the new end of the queue becomes 9. Orange is assigned to the 9th index in the array. Okay, that's orange. Next, yellow comes, right? And yellow might come in and look and be tempted to say, oh, the queue is full. That's okay. Yellow can always go over here. There's still some space at 0, right? all of these are actually free. This is what we mean when we say it's circular. So we gotta increase the end of queue pointer. Right now it's pointing at 9. We increase it by 1 and realize, oh no, it's full. Okay, you know what? We'll just reset it to 0. Yeah, so we do have free space, but we have to start from 0 again. So we reset the queue pointer. I think it probably makes more sense to say set than reset, but I don't think that take off a point for something like that. Reset the end of queue pointer to 0. Because let's just explain why not. Because array does not have a 10th index. Have a 10th index. Then yellow is assigned to the 0th index. I think that should be enough for the full 4 points. The following diagram shows the state of the queue after several operations have been performed. All queue locations have been used at least once. Front pointer, end pointer, state the number of data items in the queue. So this one is a little confusing. I mean, it's not really that confusing, but something that might confuse you is why are there values here? Why are these not empty? So if you look at the front pointer, the second person in queue, the third person in queue, fourth, fifth, sixth, seventh, eighth person, I'll count it later. Why are they not empty? The reason they're not empty is because they have been used before, and when the front person in queue is processed, it's possible to delete it. So let's say we process this one, we could empty this data, we could remove this data, but we don't actually have to, because all we need to know is that the space is available. So we can save just a tiny bit of time by not removing it, and just when we need the space again, we're just going to override it. So for example, if you add somebody to the queue here, instead we won't bother to check if somebody is already in the queue. We'll just overwrite the amount of we'll just overwrite the data that is already there, for example with D99 or whatever. Yeah, so we don't need to worry about any data that's not already there. All we need to do is look where the front pointer and the end pointer are. So that means we have 1, 2, 3, 4, 5, 6, 7 people, 7 data items in the queue at this moment. Okay, let's move on. The design of the queue is completed and the number of locations is increased. A function add to queue has been written. It takes a string as a parameter and adds this to the queue. The function will return true if the string was added successfully. A procedure file to queue will add each line from the file to the queue. This procedure will end when all lines have been added or when the queue is full. Describe the algorithm for procedure file to queue. Okay, we want to write file to queue, and we can use add to queue. Yeah, so we don't need to worry about how to add something to the queue. We just need to worry about adding stuff to the queue from the file. So what's the first thing we need to do? We need to write it in structured English. we don't use pseudocode. So the first thing we need to do when we're dealing with file operations is open the file, obviously. Open the file. Specifically, we don't want to write to the file. We want to read from the file. Also, at the end, I always forget when I'm feeling stressed in the exam, I always forget to close the file in the end. So I just make a habit of doing it first thing, so that the chance of forgetting to close the file is very small. Okay, once we've opened the file, and we're gonna close it later, we need to start a loop. Start a loop. Start a loop. And then we're going to start reading line by line, starting with the first line. Okay, I'm going to just write it a bit weird. Read the next line. Read the next line. But I didn't yet define what should be the first line, so I'm just going to put it here. Starting with the first line. After reading the next line. After reading the next line, or starting with the first line, we're gonna add it to the queue, right? Use the function add to queue to add the data we just got. Use the function add to queue to add the data we got in the previous step. But we got to be careful, because once we use the function, the function might actually return an error message, yeah? Because the queue might be full, correct? So let's check that. Check if add to queue returned false. Check if the function returned false. If so, break the loop. Break the loop with an appropriate error message, with an error message. Okay. So, like some kind of message like, sorry, the queue is full. Aborting. If another thing, so right now we only have one way we can end the loop. The other way to end the loop is if we've read the whole file. Okay, so we're gonna see check if we've reached the end of the file. If so, break the loop. With a success message. Good. Let's see what's next. A function getNum will take two parameters. Oh my goodness, we're only on question 4. How much do we have left? 4, 5, 6, 7, 8, Well, I'm not really looking at the clock because I'm spending a lot of time chatting. But obviously, if you are taking the exam, you have to be careful that you are not. You have to be careful to keep an eye on the clock because you really don't want to spend too much time on the really easy ones and then lose all your points on the. Yeah, you get it. Okay. A function getNum will take two parameters, a string and a character. Count the number of lines that the character occurs in the string and return the count. We finally get to do a pseudocode. Okay, any comparison between characters needs to be case sensitive. For example, character A and character A are not identical. Great. Write pseudocode for the function getNum. Okay, functions. First thing, we're gonna get at least 1 point by doing the function header and end function correctly. But don't forget the end function. How do we do the header? Function getNum. So first the keyword function and then getNum, the function identifier, and then open brackets and all the inputs. What inputs do we have? Or all the parameters? We've got a string and a character. So I'm just going to write text dot is string. And then chara, short for character, is char or car. Oops. I told you I wouldn't use backspace. I wanted to use undo. Okay, let's do it. This should be fine. Returns. What does it return? It returns the count. Returns an integer. Now we gotta go all the way down here. Don't forget the end function or you're losing a point for no reason. Should be happy if you do this because you got at least 1 point. Let's see how many more of these 6 we can get. Next, we're going to take count. We're gonna need the inset again. So let's see. We're gonna need a variable counter, which is gonna be an integer, and we're gonna initialize it to 0. So the counter starts by assuming that the character never occurs. So declare counter integer. And we're going to initialize it to 0. Counter gets the value of 0. Right? Okay, so far so good. Next, we want to loop through each of the letters in text. And do we know how long the text is? Yeah, we have a function for that in the inset. So we're going to do a for loop. If you know how many times you got to loop something, you use a for loop. If you don't know how many times, you have to use a while or a repeat loop. And then add the exit condition. So I'm going to do a for loop. For index, just use I for index. Index gets the value of, maybe I ought to declare index as an integer. I don't remember, do I need to declare it as an integer? Anyway, let's just be on the safe side and declare it. Declare. Let me know in the comments if I need to do this or not. I forgot, if I'm honest. I'm not taking the exam, so I don't need to memorize this stuff. But you are taking the exam, so you do need to memorize this stuff. For I is, we're going to start at index 0. Maybe I gotta look at the inset first to be on the safe side. And then it's probably string and character for, yeah, mid. We're going to use mid, and mid has a string x, y, x and y. And y is the starting point of length y, and the length of what's returned is specified by y, and the starting position is specified by x. So for example, if the starting position is 2, we got b. Okay, so it starts with 1. We need to start with 1. 2, and then we got the length. The length returns an integer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Length of text. And then we're gonna need an end for. Don't forget the end for. Give my skip some space after the end for. We won't need to do anything except for return. Okay. End for. And then I'm going to return counter. I may as well do it now, even though I haven't calculated it yet. We get the points. We probably get a point for a for loop. We'll probably get a point for returning a counter, even if we leave this blank. Okay, let's see if we can get the remaining points. So we got 3 points, and we have 3 more points left. We want to get another. My handwriting is so bad. Okay, we want to check. Okay, first thing we're gonna do is we're gonna declare one more thing. I should have left a bit more space up here, but let's write it up here. We're gonna declare another variable, a letter, and letter is gonna be a car. So first thing we're gonna do is we're gonna take letter, and we're gonna assign the if character of text to letter. So letter is assigned. Remember, it was mid. We just saw this mid text, and then x was the first one. No, what am I doing? The if. Yeah, the first letter is. We start first. It's going to be the first letter, then it's going to be the second letter, then it's going to be the third letter, all the way up to length. And how long do we want to return it? Well, we know. So in other words, y is going to be the length of the string that's returned by this mid function, and we only are interested in cars. So y is always equal to 1 in this case. So it's going to return only a string of length 1, which is a car. Okay, now we've got if letter is equal to Kara, which is the input letter, then don't forget the end if. Leave some space. What do we need to do? We just need to increase the counter by 1. Counter, the new value of counter is assigned the previous value of counter plus 1. I think that's it. Yeah, that's it. Pretty good. Let's save. Let's move on with the next question. A programmer has produced the following pseudocode to output the square root of numbers from 1 to 10. 9 numbers are for reference only. Okay, so we don't really need to worry about that. Declare num real. Okay, we got a number which is real and it's 1. Repeat, so it's looping it and it's incrementing the number every time, so it starts with 1 and then 2, 3, 4, 5, 6. Display squared, probably display the square root of the number. It's calling this function. So we call this function and we have a byref. You know what byref means? Byref, if you don't remember, is that I'm calling not really the number itself, but I'm calling the address. Yeah? It's kind of similar to using global. So in a simple way of expressing it, if we use byref, then any changes I make here will affect this num variable. Output this num. Okay, so we're going to just print it. And then we're going to calculate the square root of it. Okay, I see the problem. It's going to change the square root. It's going to change the value of this local variable, which is in fact also going to change the value of this, right? Because we've done byref. And then it's going to say la 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 la, and then increment this, but it's already been changed. So the program code compiles with error, but the program gives an unexpected results. These are caused by a design error. Explain why the program gives an we're gonna say byref was used. That's the reason. We got 3 points, so we gotta explain it in 3 points worth of detail. Let's see. We're gonna say first of all byref was used instead of byval. This is probably gonna give us 1 point. The program uses and the procedure uses byref instead of byval. This means the value of num. This means the value of num will change every time. This means the value of num will change every time the function is called, the procedure is called. The procedure is called. That's 2 points. How can I get the third point? I have no idea what else to write. So, okay, we'll just give a specific example. For example, when num is 2, the procedure will change the value of num to the square root of 2. And then, okay, I think it should be fine like that. Maybe I won't get 3 points. I don't know. It's clear. I think it's clear to the examiner that I understand exactly what is going on. So I hope to get 3 points. But I only really mentioned 2 concrete things. I don't know what the third thing is they're looking for. Anyway, let's just hope for the third point. Explain why the compiler does not identify this error. That's easy, right? There's no real syntax mistake. There's no mistake in syntax. there is no mistake in syntax as far as the computer knows. I'm doing like this. Knows. It doesn't really know. Computers don't really know things. They just code data. As far as the computer knows, this is the intended output. Okay. Describe how a typical integrated development environment could be used to identify this error. So for example, we've got bug tracking. We can add breakpoints to pause the code as we run. While paused, we can inspect the values of variables. While paused, we can inspect the value of variables. Let's see. What else can we say? I only put 2 points and we want to put one more. ID, can you... I'm gonna pause and come back to it later. The pseudocode is converted into program code as part of a larger program. During compilation, a complex statement generates an error. The programmer does not want to delete the complex statement, but wants to change the statement so that it is ignored by the compiler. State how this may be achieved. Okay, the program does not want to delete the complex statement, but wants... Okay, we can just comment it out. This state, we don't need to explain why it works. Comment it out. So we still have what was written there, but we can just kind of temporarily remove it by using comments. I do that all the time. Okay. A procedure square will take an integer value in the range of 1 to 9 as a parameter and output a number square. The boundary of the... Oh, this is a fun one. The boundary of the number square is made up of the character representing the parameter value. The inside of the number square is made up of asterisk character, like this. We got output. Okay, output, they're just saying, don't worry, you don't have to worry about starting a new line. Yeah? So we don't have to worry about the line feed. Output does an automatic line feed at the end. Okay, so there's multiple ways of solving this. You know what, I'm thinking it's only 9. So one sneaky way of solving it is just saying, if parameter is 1, you do this. If parameter is 2, you just output this. If parameter is 3, we output this. If parameter is 4, okay, let's do it like that. I don't know if they were intending this. Anyway, we're gonna get 1 point for procedure square for writing the header of the procedure and end procedure. So we've got procedure square, open brackets. The input was, what was it? An integer value. Let's call it size. Integer And then I'm gonna go all the way down and do end procedure. And procedure. That banks 1 point. If we don't forget the end procedure, because in this way we bank 1 point. That's 1 point in the bank. Nice. Remember, procedures don't return anything. Okay. Now let's do it the sneaky way. If size is equal to 1, it's gonna hurt my hand though. Output. What was output? What was the syntax of output? Let's just do like this. I think it was like this, right? And if. Let's do else if to save space. Else if size is equal to 2, output 2, output. It's gonna hurt my fingers to do it like this though. Because I have to write so much. I hope I have enough space. Else if size is equal to, I'm gonna start writing smaller actually. Pre output pre output pre start pre output pre. Okay, and we just continue like that, but naturally there's a much more elegant solution. I don't know if they messed up. I didn't realize this obvious solution because it's only 9. I don't know if they intended it, but you know, let's do the elegant solution because it's good practice. Let's delete all of this. Oh, this is just the backspace. Undo. It's faster to use the eraser. Surely, or maybe just a if I press backspace now. Yeah, like that. Okay. Okay, so let's make a bit more effort and say we're gonna use loops. We need to make sure that 1 and 2 are working though. So it's not that easy actually to use the elegant solution. Well, let's just make exceptional cases, an exceptional case for 1. And then for 2 onwards it should be okay. So we just do if size equals 1, then if size equals 1, then, and then else. And I'm also gonna put my end if over here. If size is equal to 1, then output 1. Next we're going to calculate how long. First of all, we're going to calculate how many stars we need to add. Yeah? I mean, how many columns, how long each of these rows needs to be. So we're going to declare a variable. declare row length is an integer, and we're gonna say, oh, sloppy. I'm getting already a hard time focusing because I'm already a bit tired. So it is quite a challenging exam, huh? Don't say I said it was easy. Row length gets the value of size minus 2, right? So in the case of it being 2, it becomes 0. And in the case of it being 3, it becomes 1. Why I wanted to do an exceptional value for 1 is because in the case of it 1, it becomes negative 1. And that might create some weird artifact to do a for loop from 0 to negative 1. Confusing, right? I just want to avoid that whole can of worms. That's why I made an exceptional value for an exceptional case for 1. For the remainder, we should be fine. Row length is equal to size minus 2. Yeah? Remember also, if you don't know how to solve it, you're already going to get a point for procedure for this header and end procedure. You're also probably going to get a point for doing something like this. So you may as well get started. Even if you don't complete it, you're still going to get partial credit. Very important to get the partial credit for those questions which you don't know how to do. Yeah? You don't need to aim for 100%. Just aim for 60%. I don't remember the grade thresholds, but you really don't need 100% to get an A. Okay? Anyway, let's continue. Row length, we know the row length. And now we're gonna do the upper thing. We're gonna do, if it's 2, we're gonna do 2 rows. Okay. We're gonna do 2 columns, etc. If it's 3, we do 3 columns. By the way, in case you don't realize what I'm talking about, I'm just thinking for now about the top row. So we're gonna do 4. I gets the value of, starting with 1, 2, 2, for 1, 2, size. And then we're going to, first of all, you know what, we're gonna need to do that. Oh, it's quite difficult. Okay, first we do the first row. Yeah, fine. Oh, I don't know what to do. Okay, let's see. We're gonna say I need a text. I need to declare another text. Declare top row is a string. For I is 1 to size. The initial value of top row is going to be an empty string. And now let's have a look at how to append string values. I believe there was something in there. Here, concatenates 2 strings. Yeah, this ampersand sign. So we're going to create the top row. Top row gets assigned the value of the previous value of top row, ampersand, size. No, but we need the not the integer size. We need, well, it's quite a tough question for just 6 points. We need the car of size. We need the car of an integer. Car of size. I have to say it's quite tough, but you can get partial credits easily. And that should be enough to declare the top row, which is also good for the bottom row. Right? Top row and bottom row are the exact same thing if you look at the question. And once we have the top row, we can output top row. Output top row. Next, we want to declare bottom row. We're going to declare a new string. Declare mid row. Mid row is a string. I'm going to do the same thing. And the initial value of mid row is jar of size. Right? So the first value of the middle row is the number. And then we're going to concatenate as many stars as we need. Yeah. So we're going to see for I is 1 to row length. Mid row and yeah, so we're going to add stars. We're going to add size minus 2 stars and 4. And then we have to add one more character, one more mid row is if, and one more question, if okay, I should have made, okay, I'm going to leave it like this. So if size is 2, we're actually doing this from 1 to 0. What's going to happen in this case, I'm not actually sure. But let's leave it like this. We might not get 4 points. It's not the end of the world if we get 5 out of 6. Okay, mid row is equal to mid row, and the thing is, if I try to correct it now, I might make such a big mess that I'm gonna get even less than 5 points. So I'm just gonna hope that I get 6 points, but I'm gonna accept the fact that I might get 5. But because I don't want to make such a mess that I end up getting like 1. Yeah, okay, plus car. And anyway, I'm showing the examiner that I'm making a pretty good, complicated, that I'm pretty good at system thinking. Yeah, that's what I'm showing the examiner. Mid row gets assigned the value of mid row and the character value of size. Yeah, so now we've got the character value of size, stars, character value of size. Then now we have the top row, all the middle rows, and the bottom row. So let's do this. We're going to just do another for loop. For I gets the value of 1 to size. No, we've already outputted the top row, so we're going to do row length again. And we're going to output mid row. And then we are going to end 4. And then now that we've got everything. If I didn't make any mistake, now we've got everything like this. We got the top row, all these mid rows, and now the last row output top row. I think that's good. Check me at home. Let me know in the comments if I made any mistakes or if I have any oversights. Or do you think it's gonna work? I don't know. Next question. Oh, thank goodness. I'm a bit tired. We don't have a pseudocode, so we get a break from pseudocode. A computer system for a shop stores information about each customer. The items of information include name and address, together with payment details and order history. The system also stores the product categories they are interested in and how they would like to be contacted. The shop wants to add a program module that would generate emails to send to customers who may be interested in receiving details. Okay, pretty simple question. State 3 items of information that the new module would need. Justify your choice in its case. Okay, we want to add emails. And do we have the email address? Yeah, we already have the email address. Let's underline what information we already have. So name, we already know the name, we already know the address, both postal and email. And we already know the order history and like the payment details. There's no product category, categories of interest and contact preference. Now let's underline what we want. The shop wants to add a program that would generate emails to be sent who may be interested. Okay. Out of these, what does... Okay, they'll need the emails, of course. They will need... we don't need the payment details. We don't need the name. Emails and or post contact preference. Okay, depending on the contact preference, they need to know where to send. On the contact preference, they will need to know where to send the letters. The module needs to know how to contact customers. Name, to personalize the communication. So if if you get like an email from somebody, to whom it may concern or whatever, or dear Madam Sir, you don't really necessarily feel like it's directed towards you. But if you add the name, it feels a bit more like, oh, this email is for me. Contact preference, to pick an appropriate a communication method that the customer actually likes. Okay, that's pretty easy points. At least I hope they're easy. 2 items the customer information that would not be required by the new module. The order history or the interests. Okay, what does the module want to do? Details, send information about details of new products that they might be interested in. So they will need the categories of interest that have expressed. The order history would also be necessary. I don't know. I think they'll need all of this. But does the information really need to come from here? Oh my gosh, this is a weird question. I don't think it necessarily needs to come from this list of things that the shop needs, but we can make up our own stuff. Using the order history is obviously necessary to determine, is obviously useful to determine what customers are interested in. Also, the product categories that they're interested in would also be useful. So what would not be useful? Well, it depends on how you mean required. It's not absolutely necessary. Okay, to be honest, I have no idea what to answer here. So I'm going to guess something. I'm going to take one from here and one which I'm just going to make up. And hopefully I get 1 out of 2, or maybe 2 out of 2. Anyway, I don't want to spend too much time on this question. It's only 2 points at the end of the day. Let's say order history. Order history. The order history is very useful. Is not absolutely. It's useful, but it's not absolutely essential in determining user preferences. And then what's also not useful is personal, like marital status. Let's see, marital status of the customers. Such a weird question. The marital status. Is not useful information. It's not useful at predicting preferences. When we already have all this big data, we don't need this. I'll leave it like that. Hopefully I get 1 point. The program includes a module to validate a personal PIN number. This is used when customers pay goods using a bank card. The state transition diagram has been produced for this module. The table shows the inputs and outputs and states for this. Okay, easy one. Hooray, easy one. Complete the state transition diagram to represent the information in the given table. Okay, so let's read this. Let's say this is the start, and then immediately go to S1. So in S1, we get a pin. And then the next state, we go to S2. So we got to draw an arrow. After entering the pin, we get, we always go to S2 no matter what. Yeah? And then when we're at S2 and we get the input re-input pin, display error. Then we go to S2 again. Okay, so S2 is the error. So invalid pin. In case of an invalid pin, okay, anyway, when we're at S2, we have 4 options. One option is to go back to S1, which is already here, in case of cancel and reprompt. Yeah, okay, I'm getting it. S1 is a prompt. So once we've gotten the pin, here, input pin, once we've gotten the pin, we go to S2. Now we're at S2 and it's checking the pin. It might cancel. Zoop. Reprompt. Go back to the prompt. It might re-input pin, and then you display an error and it goes back to S2. So we're gonna re-input pin, display error. So we got this one, we got this one, we got this one. Next, S2, valid pin, enable payment. We go to S4 in case of a valid pin. S4, valid pin. Why do I keep doing an R? Who knows? Pin, enable payment. My handwriting is just terrible. I'd be able to rotate the screen, you know, and rotate. In fact, why don't I just do it? I actually can. Okay, and then the last option is S4. Too many tries, block account. That's a bit harsh. Just block the card. You don't have to block the whole account. Block account. Anyway, that's what it says. Okay. Okay. Good. I think that's right. Let me know if I made any mistake. Okay. Let's save it. We're getting there. Oh, in fact, I have to go soon. I'm gonna need to take a break and I have to go to class to teach, so I'm gonna pause it here, but of course from your perspective I'll be back in 1 second. See you in a bit. Okay, I'm back and now we're gonna do question 8, which is the last question on the paper, and it's a big one. At the end of the paper 2, they usually have a big question. As you can see, we have a big 7-pointer followed by another 7-pointer and then 3 points. So these ones are quite challenging. 17 points out of a total of, what was it? 75. 17 points out of 75. So remember, they're often quite challenging, but if you get partial credit on them, it already goes a long way to getting a good grade. Let's see. A computer shop assembles computers using items bought from several suppliers. A text file stock.txt contains information. Okay, we got a text file. Information for each item is stored as a single line in the stock.txt file in the format item number, supplier code, description. A valid item, we've got the item number part, it's got 4 numerical characters. So for example, each line of the text file has, has like 5668, for example, then 3 alphabetical characters, B, C, F, for example, and then a minimum of 12 characters, which is a string, like I don't know what, funny games, 1 2 3 4 5 6 7 8 9 10 11 funny games, exclamation mark, right? This would be an example of a valid line in the text file stock.txt. So let's continue. The file is organized in ascending order of item number. So basically the first is going to start with 0001, and then it's going to be something higher than that, etc., etc. And does not contain all possible values in the range. So some numbers are going to be skipped. A programmer has started to define the following program modules. Only alpha. It's a function. It returns true if the string in the parameter contains only alphabetic characters. So I assume no numbers and no exclamation marks and stuff like that. Check info. Called with the parameter of type string representing a line of type information. So we've got a string that goes in here. And this string is going to represent a line of item information. Okay, so the item information, if you remember, will be all of these codes combined, I assume. Checks whether the item information in the string is valid. So it has to fit these criteria. And it returns true if it's valid, otherwise it does not return. Otherwise it returns false. So let's have a look. Write pseudocode for the module check info. Okay. The module only alpha should be used as part of your solution. So in other words, we don't have to work on this only alpha. We've got this. It already exists. We don't have to write it. We just have to we have to use it. But we have to focus on writing check info. So let's see, it's a function. We know it's a function because it returns something. So we're going to start with the function header and get 1 point just for that. I mean, the function header and end function, probably it's going to give us 1 point. Let's start function identifier, check info, open brackets, and what was it? It's it takes a parameter, some kind of string. I'm just gonna write text double dot type string, and it returns a boolean. It's gonna return either true or false. And then we're gonna go all the way down here and we're gonna do end function. Okay, so first is we're gonna get the first 4 characters, and the first 4 characters need to be 4 numbers. Let's see. Let's go to the inset. IsNum. We're going to use isNum. IsNum returns true if it represents a valid numerical value. But we can't because it's that contains the real part. Let's see. Do we have a modulus function? Yeah, we have a modulus function, so we can check if there is a real part to it. I don't know if that's the best way to do it. I wonder if they have an isInt that checks if it's an integer. String to num. Okay, let's get started. Remember how I said even if you don't really know exactly what to do, let's figure it out. So we first need the leftmost values. So we're going to use left. We're going to declare a new string. We're just going to call it what is it? Item num. We're going to call it of type string, and then we're going to give it assign it a value. Item num gets the value, and the value it gets is left of text, comma 4. So we're gonna get the foremost characters. Left of 4. Okay. Next we want to check if these characters item num are actually numbers. So we're gonna say in fact I'm gonna do item num s for item num string, and then declare item num numeric it's real. I'm probably not doing this in a very efficient way. There's probably a much more efficient way to do it. If you could do this in a more efficient way, let me know in the comments. Item num real gets the value of what was it? I'm going to convert this string into a number. String to number. String to num. With underscores. Okay. You know what? String to num. Did I do that right? No, it's str. str to num. Okay. With item num item num s. Okay, so we might have gotten somebody might have made a mistake and put a done in there. Probably we're going to get an integer. First of all, let's see if it contains any letters. So I assume that this isNum is going to return false if it contains any letters. So I'm going to say if isNum, if isNum of item num real, if not, excuse me, if not, if it returns false, if it does not return true, in other words, then we already know. Then we already know return false. Else if so this still doesn't cover what would happen in case somebody put a decimal point in there by mistake, right? We want an integer, but we might have a real. We want 4 numeric characters, but we might have a real. So we could say modulus 1. If it's a integer, modulus 1 is always going to return 0. Right? As if item num real is not equal to 0, then return false. Oh, excuse me. Mod 1 is not equal to 0, then return false. And if. Okay, so that covers the first 4 digits. I just thought of a better way to do it, but I think this ought to work. But what another way would be to do is just to loop through the first 4 characters. So first get the first character and check if it's a number between 0 and 9. Next get the second character and check if it's a number until you get all 4. That I think would probably be a better way to do it. Anyway, let's move on. Next we want to check the supplier code. Yeah, so we need to make sure that the supplier code is contains 3 alphabetical characters. So we're gonna get the next 3 characters. Let's get declare. What is it called? Supplier code. It's a string. And then we want to get a value for supplier code. Supplier code is assigned a value, and we're going to use mid, and we want to use text, and we want to start with the 5th value, and the supplier code is always pre-long. So now we got supplier code. Next, we want to declare a new boolean. Declare is as supplier code. We don't really need to do this, but I'm just doing it in a more easy to understand way. But you could do it in one step. Is supplier code alpha boolean? And then we're gonna say is supplier code alpha gets the value, and the value should be the output of this pre-written function only alpha. Only alpha. And let's see, how did only alpha work again? Only alpha gets a string input and returns true if there's only alphabetical characters. So we have supplier code. We want to check if the supplier code has only alphabetical characters. Now, if it does not, if not is supplier code alpha, then return false. Okay. And then end if. Okay, next we want to make sure that the last part is at least 12 characters. So we want to check if 4 plus 3 plus whatever plus 12. So the minimum length of the whole thing would be 4 plus 3 plus 12. Okay, so I'm gonna declare main length, which is an integer, and min length in fact this could be a constant, but whatever, I already declared it as an integer. Min length gets the value of length of text. Right? So, oh, I'm stupid. I've been working too hard. Min length is 4 plus 3, which is 7, plus 12 is 19. Min length is 19. I'm doing it in a bit of a roundabout way, doesn't matter. And then, okay, so now we have to do if length of text is smaller than min length then return false. And if Okay. I'm just wondering, what if somebody made a mistake and made this code? Okay, I'm overthinking it. I think this should be fine. So if none of these errors happened, so if this error did not happen, this error did not happen, and this error did not happen, and this error did not happen, in this case, return true. In fact, return should end the function right there. But if you want to do it in a slightly different way, we're going to declare a flag and we're going to give it and it's going to be a Boolean. And instead of returning false here, and then flag, the initial value is going to be true. And here, everywhere I've written return false, instead of returning false, I'm going to set the flag to false. So I remember vaguely in the back of my mind that in pseudocode the return might not actually stop the function there. In most programming languages it's gonna stop the function there in its track. But to avoid the possibility that it doesn't actually, and it actually continues, I am going to, it returns multiple values. I'm going to do it like this. I don't think it should be necessary. But this will work just as well. Any of these events may cause the flag to change value to false. And then at the end, after all this checking, we're simply going to return the flag. And I think that should get most points. Okay. Next, a new module is defined as follows. Add item called with the parameter of type string representing a valid information for a new item that is not currently in the stock.txt file. Okay, so add item is going to add a new value to the stock. Creates a new file, new stock.txt from the contents of the file stock, and then adds the new item information at the appropriate place in the new stock.txt file. Why? Okay, right. Because it has to be in order. So what it's going to do is going to go to open the stock.txt. It's going to read the first line, and if the first line, the item number becomes before, then it's going to just transfer that item to the new stock. And then it's going to read the next line, and if that item comes before, it's going to transfer that item too. And it's going to continue until we finally reach a situation where the new stock has found its right place in the order, and in that case we're going to put in the new item, right? And then we are going to continue with the rest of the stock file. Only I kind of don't remember how to do files. Let's see, what was it? It was open file for write and open file for read. But I forgot the specific syntax, I'm afraid. Remember, I'm not actually taking the exam, so that's okay. I can just look it up. But you are going to take the exam, so make sure you remember all this in advance. Memorize all this in advance. I'm going to check. I'm going to pause the video and check the appropriate syntax. Hold on, I'll be right back. Okay, I'm back. So, we have to start by opening a file, which was the command, open file, then the file name, stock.txt, for we're reading it, read. Open file, we also want to open a new file, which is called new stock.txt. So if you're like me and you forgot, just guess something. Hopefully you'll be okay. Hopefully they'll give you points. But I didn't want to confuse you. I would have just not looked it up, but I didn't want to confuse you with the wrong syntax, so that's why I decided to look up the syntax first. Okay, we've got both the files open. Don't forget, we're also eventually going to need to close the files. So let's go all the way down here, and we're going to do close file. What was it? Close file. Close file. Stock.txt. Close file. New stock.txt. Right, okay. I'm pretty sure that's at least 1 point out of 7. So that's a good start. Next, we're gonna write a loop. Do we know how many times we have to loop? No. So we're going to use a while loop or a do while, a repeat until. Let's use a repeat until, so that we can come up with the ending condition later. Repeat and then all the way at the bottom we're going to write until. In fact, I'm going to do one more thing. I'm going to just scratch this off, and I'm gonna before we get started, I'm gonna declare some stuff. I'm gonna declare an exit flag. I like working with exit flags because I find it quite intuitive. And the exit flag is Boolean, and the initial value of the exit flag is false. What else do we need? We're gonna need we're gonna need a number. Oh my goodness. You know what I forgot? I forgot the most obvious thing. I forgot the function header. Let's do it over here. Function add item. what's coming here? We got a parameter of type string, which represents valid information. Good, so we don't need to check it. So we're gonna just call it new item. And it's a string. And it's going to return something. Do we need to return something? Yeah, let's return true or false if we succeed or not. I already forgot something else. I forgot to try to open the file. And if you don't succeed in opening the file, it's going to return false. Anyway, let's leave it for now. Don't forget the end function. We might get a point for that. But I don't really have space to write it in. Oh my gosh. Okay. Let's get the value of the first 4 letters of the new item. So new item, what was it called? I keep forgetting. Item num. Let's declare. Let's get some more, collect some more points. Oh, see how to handle this try and catch later. Declare item num. And it's an integer. Let's see if we can do this all in one go. We know it's valid, right? So item num gets the value of, hold on, in set gets the value of string to num, and it's going to return an integer. So item num gets the value of str to num of mid of new item. No, we didn't need mid, we need left. New item. You can do it with mid too, but it's easier to do with left. First 4 characters, close brackets, close brackets. Okay. So now we have an integer which corresponds to the item number. And now we need to repeat. We need a loop. I don't think we need any more variables, right? It should be okay. So we're gonna do repeat. Until exit flag. So if exit flag ever becomes true, we're gonna exit the loop, right? Okay. Then we're gonna, the good thing about doing it this way is we don't have to worry about the exit condition for now. Read the first line of the stock. Let's see. we'll put it in a variable, it's easier. I'm just going to declare a variable here. Ah, that's my son. I'll be right back. Yeah, 1 second. Okay, we're gonna declare index or item num old. Not a very good name, but I'm tired. String. Right? And this string, we're gonna, first of all, we're gonna read it. What's it gonna declare line? I'm gonna do it in multiple steps. It's easier to do it in multiple steps. Declare line as string. Okay, so line gets the value. Oh no, it was a different syntax. How annoying. It was read file. If I recall correctly, it was read file. And then the name of the file. And then it was the name of the variable where we need to store it. Let me just double check myself. Is that correct? Yeah, like that. Okay. With a comma over there. You won't be able to double check yourself in the middle of the exam. So memorize. We got the line now. Next we want to do item num old, and then we've got item num old. It's gets the value of just the same as what we did here. String to num of left of line 4. Okay, so now we've got the item num old, and now that we know the item number and the old item number, we know if we ought to transfer to the other file, transfer from stock.txt, or we've got to add a new item. So we're gonna say if item num old is smaller than item num, in this case, then what happens if they're equal? If I remember correctly, they can't be equal, right? Oh my gosh, I just remembered something. I made a big mistake up here. I forgot that this only goes up to 5. Anyway, we're going to come back to it later. You see, this is why you always have to read the questions very carefully. Let's see. Item num, can they be equal or not? I think item num is always a unique. Yeah, a unique number. So we don't have to worry about the case that they're equal. Okay. If item num old is smaller than item num, then transfer. Okay, so that means we're going to write the line to the new file. Write file. The name is new stock. .txt, and then comma line. Let me just double check if I'm correct or not. Yeah, write file, file name, comma. Okay, that's right, I believe. Else first we're gonna write the input. Oh, I'm stupid. Okay. I need another flag. That's okay. We're gonna declare another flag up here. Hold on. Because we don't want to, we only want to write the file over. We don't want to write the file over every time it's larger, just once. So we're gonna need another flag up here. Let's do it up here. Declare written, like has the record already been written, which is a boolean, and written gets the value of false. So we only want to do it once. So else, if not written, then if not written, then written is true, and we want to write the file. This is a nested if, by the way. Write file, new stock, .txt, comma, new item. And then don't forget we have to write the current line as well. Write file, new stock .txt. I hope the examiner can read this. Let's cross it out and write it very neatly. Okay, better than nothing. Good enough. I'm gonna make an even bigger mess if I do it again. Line. Okay, so after that we have to write the current line we are reading from stock.txt. And then else. So if it has already been written, then just write the file from the old, the line from the old file as usual. New stock.txt, comma, line. And now we got an end if over here. And we also have an end if because of this if. Okay, and then we had to deal with the exit flag. Otherwise, we're going to go on forever. The exit flag is going to be... okay, it wasn't really necessary. We've got this end of file function. Where was it? No? Yeah, in here we've got an end of file function. Where's end of file? The function end of file is used to test whether there are any more lines to be read from the file. So we're gonna say, wait a minute. The function returns true if there are no more lines to read, and it returns false otherwise. I'm just wondering, is this in the inset? I don't think so. Yeah, they have it in the inset. Okay. For some reason, this they do have in the inset. EOF returns Boolean. So exit flag gets the value EOF stock dot txt. So if there's no more lines to be read, it's gonna exit this loop. Let's see. One thing I mentioned is I didn't do a try and catch. So we can very quickly here try. Why not? And then let's cross this out and move it up here. We'll cross these out until exit flag, close file, close file again, stock.txt, new stock.txt, and then here we're gonna do catch, and then and try. I think that's the right syntax. This one I also forgot. Let's just Google it to be on the safe side. Exceptions. Okay. Unbelievable. Oh, we don't have a try and catch. Okay, let's just forget I said anything about try and catch. Basically, try and catch just means try it, and if there's some error, then we're gonna handle it. Oops, undo. Okay, then there was one more mistake I made up here, which is I forgot one of the things. If it's greater than 5999, then we've got to also return something. So we're gonna just fill it up here. We can do it down here too. So one more if. If, where was it? Item num real is greater than 5999, then and if. And then over here we'll put flag false. So any of these conditions will set the flag to false. Okay, the program contains modules sub exists and check supplier. These have been written but contain errors. These modules are called from several places in the main program, and testing of the main program has had to stop. Okay, right. Identify a method that can be used to continue testing the main program before the errors in these modules have been corrected, and describe how it works. It's a free pointer. I remember stub testing. If it was something like that. Stub, I don't remember the exact word. But basically replace the functions, the modules that contain errors with simple dummy modules that give reasonable outputs. This way you can test the main part of the program, and then you can fix the other modules later. Okay, I'm not sure about the last one. I'm just gonna check that one to see if I'm wrong or right. I'll get back to you. Okay, I'm back. I just had a quick look at the mark scheme, and in fact I was right. Stub testing. The modules supply are replaced by dummy modules, that's what I wrote, which return unknown results and contain an output statement to show that they have been called. Give reasonable outputs. Yeah, I'm gonna get a 3 points out of 3 for that one. Okay, so that was pretty exhausting. That was more tiring than I expected. I definitely have a lot more empathy with you students because it is pretty hard. As you can see though, it's actually quite doable. The main thing is don't panic, and the other main thing is memorize all the pseudocode. And the other main thing is you need to get practice in systems thinking. And the best way to do that is do as many past papers as possible. Okay, that's it from me for now. I will see you in the next one.